you look out on the streets, you'll see the same type of a setup. Poles, wires, transformers, fuses, switches. So we use this piece of equipment to talk about electrical safety, some of the things that our crews have to deal with, about customer safety, about why you shouldn't touch down wires, about what it sounds like and looks like when a fuse blows, what an arc looks like, and we talk a little bit about electrical injuries. So before we get started, I want to talk about, as we talked earlier, safety is the key most core value with Pepco. Mr. Hashball is wearing what we call PPE, personal protective equipment. He's got on dielectric boots, FR clothing, which is designed not to support combustion. He has on a hard hat, safety glasses, and his sleeves and gloves are both rated for 20,000 volts. Now every morning and every time before we do this test or this exercise, he does what's called a roll test, and he takes that rubber glove and he rolls it up to see if it's going to hold air, because if it doesn't, that pinhole could cost him his life. It's a process for the electricity to find a ground and could injure or kill him. So again, this is our means of protection. He also has what's called a hot stick. That's a fiberglass piece of equipment that's rated for 100,000 volts per foot. So theoretically, he could work 600,000 volts, but he wouldn't do that. So what you're seeing here is two means of protection. Everything he does is going to have two means of protection. Never is going to just pick up a down wire with his gloves on. He's always going to use that stick. Even if he's up in a bucket, that bucket is insulated for 100,000 volts per foot. So what we're going to demonstrate here today is we're going to cause an outage. We're going to blow a fuse. That could be anything like we talked about earlier, a tree limb, a car accident, a squirrel. So he's going to introduce a fault on this system. It's energized right now. So what you'll hear is, you're going to hear a fuse blow, which is going to sound like a 12-gauge shotgun blast going off. So if anybody's a little sensitive to noise, you might want to cover your ears. Mr. Hashball, whenever you're ready. Okay. Now, essentially, told you. Now, let me tell you something. That's a very controlled situation. That's a 2-amp fuse. We don't have 2-amp fuses on our system. They're much larger. So a lot of times when a customer calls in and says, I heard a transformer blew up, 9 times out of 10, it's a fuse blowing. When that blows at night, it gives a nice bright color, sometimes a little bit of fire, and obviously a loud noise. So now you've got customers that are out. They call into Pepco, they give us their outage information. We send a trouble truck out to take a look at the problem. The first thing he's going to do is he's going to find out the fact that there's a fuse blown. And he's going to go through his process of starting to safely isolate that problem. So what he's going to do is he's going now to get what's called a keep out tag, and he's going to hang that there so that in a large event, when we have hundreds and sometimes 1,000 crews on the system, nobody comes behind him, sees this fuse open, and rehangs the fuse. If they were to do that and he was downstream, he could be injured or killed. Electricity travels at 186,000 miles per second. The arcs have been measured as high as 20,000 degrees. You do not get a second chance with this stuff. You have to follow the safety rules. What he's done now is he's installing portable grounds, and essentially what that is to give him a safe work location. I mentioned earlier this is like our 3-phase system, A, B, and C phase. B phase is de-energized. A and C is still in and operational and hot. If he was working on this de-energized line and a tree limb were to come down and cross from the energized into the de-energized, all that current could go down the line to where he was working and injure or kill him. So these portable grounds gives him a safe work area. Now what he's just done in about a minute and a half in the field can literally take hours. You have to take your truck, set the truck up, put the ground in, come back down, make the truck safe, go to the next location. That's why a lot of times customers will tell us, we've seen Pepco up and down the street 3 times and my lights are still off. They're doing a lot of this work. They're identifying the fault, they're installing grounds, then they go back and restore the problem, or clear the problem and restore the electricity. So what he's done, he's going to remove these grounds, he'll make sure that there's no other fault. If it's clear, he'll put the fuse back in. And the whole time he's doing this, he's in communication with our control center. We can control the entire system underground in a location in Bethesda. But one of the reasons we stay in communication with our guys is so we know what's going on. Every step they take is recorded. It's over communication lines, both either cell phone or radio, and each step is recorded so that we know what they're doing and where they are at the time. So what you'll see here is he'll put these switches back in, these blades back in, and we'll have our power back. Now if you'll notice when he does this, he'll drop his head. That's another safety precaution. This equipment does fail routinely. If you're looking at that, the arc alone could blind you. Anybody have any idea? We just mentioned about the current that's powering this trailer today. Any guesses? 13,000, 7,000. Actually, what we're doing is backfeeding this trailer with 120 volts. These transformers work very well. They take primary voltage and step it down to secondary voltage. They also will take secondary voltage and run in the secondary side up to the primary and spit out 7,600 volts. Why is that important? If you're in a neighborhood with a generator, and somebody's bought a generator, which they're low cost now, and they hook it up incorrectly, they can actually backfeed an electrical system and cause injury or death to someone. Very important, if you're going to buy a generator, spend the extra time and money to have a disconnect switch put in for the safety, not only of your generator, but for everybody that's going to be working in those events after a devastating event. The next thing we're going to show you is this is going to simulate a tree trunk. After a large event, a lot of times there's trees down. What you can't see 60 feet up in the air is that tree that's leaning, that's uprooted, may be in contact with our power line. Not a lot going on right now. A little bit of smoke, no flames, no fire. If you come in contact with that tree trunk, you've just completed a circuit, because all that energy is coming down the trunk of that tree, seeking a path to ground. If you touch that tree or come close enough to that tree, you've completed a circuit, and all that energy is going to seek a path to ground through you. And believe it or not, the human body is a great conductor of electricity. The last thing we're going to talk about, well, you're going to draw an arc? All right, we're going to draw an arc. This is, what you'll see is a lot of people have this misnomer that if you get close enough, electricity will jump out and grab you. That's not the case. If you make contact, it will do everything in its power to stay with you. So unless you can travel at 187,000 miles per second, you're not going to outrun it. What you'll see here, as he makes contact with this buckle, the arc will try to stay in contact as it's trying to seek that path to ground. Let me get out of your way here. Anytime you're ready, Mr. Preparedness. Notice that we just tripped it. Try it again. I think we tripped it. Maybe not. You notice he's got to come in contact with it. Yeah, you tripped it. Sure did. So one of the safety features, we tripped the breaker in this. Again, if you notice, now what you'll notice is, in fact, if you get a chance to Google this, Google high voltage arc. There was a utility in California was opening a set of 500,000 volt disconnects. They thought they were opening on a dead line. They were actually opening on an energized line. That arc, like you just saw here, actually goes about 45 feet up in the air before it breaks. Did it again. So the last thing we'll talk about is electrical injuries. Electrical injuries are considered 4th degree burns. They burn from the inside out. 1st degree burn, 2nd degree burn, a little bit of sunburn, everybody's had that. 4th degree burn, the amount of heat that your body is exposed to actually continues to affect your organs even after the contact is over. So a lot of times what you'll see is the victim will survive the injury and they'll go to the hospital. But what happens 24, 72 hours later is their internal organs start to shut down for the intense amount of heat that they've been introduced to. And there's nothing they can do to stop that. So that's another reason that these contact injuries and electrocutions are, if you're electrocuted, then you don't survive it. But a contact injury has more than just the injury, just the damage to the flesh and bone. It's also what can happen to your internal organs. So what you'll see here is we use a hot dog as a demonstration tool. There's a little bit of fat, a little bit of gristle, a lot of water like the human body. More of if you're some of us who eat too many hot dogs. And what you'll see here is we're actually using a rubber glove. Remember we talked earlier about that pinhole? If there's a pinhole in that, it could cost him an injury or his life. What you'll see here is that pinhole is not going to give any insulation properties at all, and you'll see the tissue damage that happens to this hot dog when it comes in contact with the buckle up there. This is the same rubber gloves that our field guys use, and it has a small hole. Where is that? Do you have that tool? It's literally the size of a small piece of wire. That's all right. Don't worry about it. So what you'll see is, again, he has to make contact. Now notice the arc that you saw before was a bluish green. Now it'll be orange because there's something there to support combustion. Notice the orange color. All that energy is going down through that hand, seeking a path to ground. Your body's taking all that heat in. Sorry. That's all right. Let's do that again. And what you'll notice when you see this is the pitting, the tissue damage, the intense heat when you feel it. It's very hot to the touch, and there's also marks on the inside. Now, this is just with a very simple contact, but you'll see the way the flesh has been pitted and blown away. There's burn marks, it's hot to the touch, and there's more damage down inside. And he'll do another one here in a second. We'll show you some more. But this drives the point home. If you're not electrically trained, if you're not a high voltage lineman, do you have any way to know whether that wire that's on the ground is energized or not? And the answer, of course, is no. And it is certainly not worth your life or debilitating injury for you to find out that question. Leave that wire alone, call the first responders, call Pepco. I'd much rather have the conversation with you that you're upset because it took us so long to get out there than I would have a conversation that someone's been injured or killed on that site because they took it upon themselves to move that wire. And I can't tell you how many times when we do this demonstration, someone tells us that they took a pole or a piece or a broomstick and moved that wire because wood doesn't conduct electricity. Well, at our voltages, it does. Again, that could be your hand or your arm. All that energy is destroying that flesh. And what happens with that, with the 4th degree burn, the 3rd degree burn, all that has to be surgically repaired, which usually means they go back to the next best joint and they amputate. So again, this is the message that we drive home every time we do this demonstration. Our guys take 8 years to become a lead lineman. 8 years of intense training. If you're not trained in that field, if you're not an electrical lineman, high voltage lineman, you've got no business in and around any of our equipment. You can start this, can you smell the smell now? The copper smell, it transfers to the flesh. We'll do it one more time and then we'll close this out. So again, the message that we always drive home with this, whether we're talking to fire, police, any first responders, or whether we're talking to a school group, is let the people that are trained to do this do their job. We'll work together to get there. I'll give you an idea. During the derecho, we had over 7,000 wires down reports, right? Less than 30% of those were ours, but we ran on every one of them. That's a resource drain on anybody. But it's better for us to go out there. That's still hot to the touch. Again, the amount of all that tissue damage, all that has to be repaired. That's not something we want to see anybody go through. In fact, we actually have an employee in the burn center right now suffering from injuries that he sustained doing his job during one of the outages we had about 3 weeks ago. We certainly don't want to see anybody, especially any of our customers or anybody in the public, having to go through that, because it is a hard, long road to deal with that. So if there's any questions, we'll try to answer them for you. Thank you for your patience. I hope we got through that quick enough for you. And this is really hot, so I'm going to put this on the glove. That's another thing I told you. That heat stays with you. There's not much you can do. So again, if there's any questions, we'll try to take them. Otherwise, thank you very much for your patience. Yes, sir.
I learned a lot today. So in this scenario I'm about to outline, if this branch were to touch a line, you were to touch this tree, did you say you could be electrocuted?
You could be, yeah.
Okay.
Because if that's completing that circuit and providing the path to ground, that energy is going through that trunk of that tree. You're welcome, Bob. Thank you all very much. Have a safe day.